Welcome back to this YouTube channel. If this is your first time with us, please kindly subscribe to this channel. We started a teaching series on number-based system, and today we'll be moving further. Today what we have is conversion of fractions in base 10 to any other bases. Alright, this is our first example here. In this video we'll be treating two examples, and this is the first one that we have. We have to convert this fraction 7/8 to Bicimal. Alright, so Bicimal is actually base 2, so what we are doing is converting from base 10 to base 2. Alright, to do this, we'll start by converting 7/8, which is a fraction, to decimal. Alright, so doing that would have 8 in 7. 7 divided by 8 is actually 0. Alright, now 8 in 70 should be 8, remainder 6. 8 in 60 should be 7, remainder 4. 8 in 40 is 5. Alright, okay, so this is equal to this. We are just expressing this fraction in decimal, so this is what we are converting to base 2. Okay, so to do that, all we have to do is to continually multiply this value 0.875. we multiply by 2 until everything that we have after the decimal point is 0. That's when we stop. Okay, so if we multiply this value by 2, we would have 2 times 5, that gives us 10. You write 0, pick 1. 2 times 7, 14, plus 1, 15. You write 5, then pick 1. 2 times 8, 16, plus 1, 17. You write 7. Alright, so this is what we have. Okay, so what we do next is we multiply 0.75 by 2. Remember, we are not multiplying this part. Okay, so we continue. What we have will be 2 times 0, 0, 2 times 5, 10, 0, 2 times 14 plus 1, 15, you write 5, and then you pick 1. Alright, so until we have 0 all through after this decimal, that's when we'll stop. So we'll continue, we'll multiply by 2 again. So if we multiply by 2, we'll have 0, 0, 2 times 5, 10, write 0, bring 1 here, 1. Alright, so at this point we can see that everything we have after the decimal point is 0. So this is where we end our multiplication. So what then is the answer? The answer is all of these digits before the decimal point in descending order. That's the answer. So we have 7/8 in base 10 equals 0.111 base 2. Alright, so this is actually the answer we are looking for. When we convert 7/8, which is already in base 10, to Bicimal, which is base 2, this is what we'll get. Now take note, when multiplying by 2, which is the base you are converting to, ensure that you multiply only what you have after the decimal point. Alright, this place we multiplied 0.75 by 2, and that gave us 1.5. Understood? 0.75 was multiplied by 2 to get 1.5, which is what we have here. So we did not multiply 1.75, rather we multiplied 0.75, because we said earlier that we are not multiplying this value that we have before the decimal point. Okay, if that's clear, let's move to the second example that we have. Alright, now let's take a look at example 2, which is very much similar to the previous question we solved in example 1. The only difference between this question and that of example 1 is that for example 1 we had only fraction, but here we have the whole number part and the fractional part. Alright, so to approach this question, the first thing we do, just like the previous example that we saw, is to convert the fractional part to decimal. Alright, and if we do that, we say 13 divided by 25, that would be 0. Then we add 0 to the 13, we have 130 divided by 25, that is 5, remainder 5. So we add 0 to 5, 50 divided by 25 is 2. Alright, so this is the decimal form of this fraction. That being said, we can now conveniently say that 19 whole number 13 over 25 is equal to 19 plus 0.52. Alright, so this particular question has both the whole number part and the fraction and the decimal part. So what we do is that we solve them separately. Firstly, let's solve the whole number part, that is 19. We are converting 19 to base 5. Remember how we do this? We say we draw a table of 2 columns, then we put the number we are converting at the right hand part, which is 19. We are converting 19 to base 5. Then we put the base that we are converting to on the left hand side, which is 5. Okay, so 5 in 19 is 3, remainder 4. Alright, so 5 in 3 is 0, remainder 3. So remember, we write the answers in ascending order, meaning that 19 base 10 is equal to 34 base 5. Alright, so with this we are done with the whole number part. Now let's look at the decimal part. Remember our previous example, we say we multiply the decimal part by the base we are converting to. In the previous video, the base we were converting to was 2, but in this question the base we are converting to is 5, so we multiply by 5. Alright, so 5 times 2 is 10. You write 0, pick 1. 5 times 5, 25, plus 1, 26, so you write 6, pick 2. 5 times 0 is actually 0 plus 2. So this is what we have. Remember, we continue multiplying by the base we are converting to until everything we have after the decimal point becomes 0. So we go again, we multiply this by 5, which is the base we are converting to. But remember, we are not multiplying this value that precedes the decimal point. Alright, we always exclude this value and just put 0 there. So in actual sense, we are multiplying 0.60 by 5. Alright, so if we do that multiplication, we have 5 times 0, 0. 5 times 6, 30. You write 0, pick 3. 5 times 0, 0. Then what you have here is 3. At this point, everything after the decimal point is 0. So we are done with the multiplication. Our answer, unlike this part which is in ascending order, for the decimal part, the answers are written in descending order. So 0.52 in base 10 is equal to 0.23 base 5. Alright, that brings us to the end of this fractional part. Alright, so how do we present our answer? Our answer is simply 19 whole number 13 over 25 in base 10 equals 34.23 base 5. Alright,